Hi, my name is Andrew Rafferty, and I chose an ice hockey skate for my reverse engineering project. One of the main reasons I chose ice hockey skates is because I had plenty of them, and it was not a big deal to destroy it. And also, I didn't think it was likely that anybody else would choose it, and I have some background knowledge with it since I've been playing ice hockey since I was about 4 or 5 years old. The first thing that I took apart was I just took the laces off. Seems pretty basic, like any time you wear something around your foot, usually has laces or Velcro. But what's different about ice hockey skate laces is their length. So it's very important that ice hockey players have strong support around their ankles. You don't want your ankle to bend at all when stopping and starting. So I measured out the laces. They're over 10 feet long, each of them. Now this is for my size skate, and I'm about 6'3", so, but usually much longer than shoes. And you tie ice hockey skates about as tight as you can, especially around the ankles. There are different types of laces. There's the normal cotton laces that you would see in sneakers, and one thing that's quite popular is they have wax laces. They tend to be more durable, and the water from when the snow and ice comes up doesn't really affect them as much as normal laces. Okay, so I couldn't really take apart the entire outer shell, but you can see that there's plenty of different components. It needs to be light enough to where you can still move fast, but strong enough to where if you do block like an 80 to 100 mile an hour slap shot on the front of your toe, it doesn't shatter your entire foot. So you can see how the front part in the left picture is made of a different material, very durable. These skates were used for about a decade, and they're still holding up pretty strong. Now, as newer skates come out, they stay with the same durability, but they are much lighter. You can see on the side there's other patches of different materials. Some is just for looks, and some like over here is for, like, if you do block a shot on the outside of your skate, there's much more padding on the outside and the front of your skate than on the back and the inside, because you're much more likely to block a shot in that area. Okay. The next thing I took apart was I took the skate blade off of the what we call toque. The toque is the white plastic that you see on the right side. It's just held together by 2 screws and rivets. Ice hockey skates, like the blades, actually do break. So if you take a shot there and it hits the right spot, it can break in half on you. So they need to be durable. They need to be lightweight, and they need to be able to be sharpened very sharp. They're actually, I think it's about 3/8 of an inch thick is the ideal width of an ice hockey blade, and about like every 4 or 5 times that a serious ice hockey player skates, they want to get them sharpened again. And again, every year they're coming out with new and new different alloys that are stronger and lighter, that can cut through the ice faster. And actually, one thing that most people don't understand is that you're not really cutting the ice, but what you're doing is you're actually melting it with the friction of the blade. That was one of the things I remember learning in my high school physics class that just blew my mind. On the right side, you can see the toque. That is generally always made of plastic, and it's just a holder for the blade so that it can connect to the boot. And we'll talk about the rivets that you can see there on the right. One of the new inventions that they have coming out is called the Mars blade. It actually has a little extension between the toque and the blade so that it can pivot while you turn. The goal of this is to keep the blade on the ice for as long as possible, kind of like the object of a speed skater. The longer their blades are touching the ice, the faster they're going to go. So as you go through a turn, the blade can pivot forward or pivot backwards and allow you to gain some momentum out of the turn. There's been a couple professional hockey players that have practiced with these, but nobody has used them in the game yet, to my knowledge. Alright, so the toques. I wanted to take the toque off, but you could see it would be pretty difficult. I spent about 30 minutes trying to get one of them out, and it was just almost impossible. Which is surprising because the skates that I use all the time, the rivets in the toque are falling out constantly. But you can see how on the left, the one tuque in the back, or the one rivet in the back, is a different material than the others. I think that's because you need more support and strength on the ends, the front and the back, to make sure that the tuque stays in place. You want to choose materials that would not react with water or rust. In chemistry we call it oxidation. So you can see how the rivet on the left, the copper ones, look like they have oxidized quite a little bit, but the steel alloys have not. Okay, so I'll go back, there's something on the screen. A couple of the questions that we were supposed to answer, like the purpose of this device. So the purpose of the ice hockey skate is to help ice hockey skaters go as fast as possible, but still offer premium protection. Because the last thing you want to do is break a slap shot, or take a slap shot and break your foot. The shape, I guess it's important for it to be aerodynamic, but I think you're splitting hairs with how much you can really do. The different shapes of the skates are not making that much of a difference. Maybe at the highest level. Weight is very important. You want it to be as light as possible. Color is not relevant except for trying to sell more. Maybe they would be more appealing to potential buyers. Made of a bunch of different materials. So there's carbon fiber on the outside, different composite materials, steel alloy for the blade and the rivets, plastic polymers for the tuques. Let's see. Ideally, you want it to be rigid, but I guess with the Marsway it's showing that a little bit of flexibility might be a good thing. You definitely want them to be durable. Hockey skates, now if you want to buy a nice new pair of hockey skates, range anywhere from like $400 to $1,200. So the last thing you want to do is buy a new pair every year. They should be easy to use. You should be able to strap them on and just go. But a lot of people stick with one brand. So I've always used CCM skates. It would be very difficult for me to skate on a pair of Bauer skates. They have different widths of the boot, and the blades are just made slightly different, but you can feel a major difference when you're skating with them. Manufacturing, I guess it'd be too complex for me to design one, but I don't think it's too difficult to assemble these in a factory. Not too complex of a design, but every year it does advance and advance and advance. So this was my reverse engineering project. I hope you enjoyed it. Thank you for watching.